All right, so today we're going to talk about the law of conservation of mass. I am outside, so there is some wind, but hopefully it won't mess up the sound too much. So the law of conservation of mass states that matter cannot be created or destroyed, only transferred. So what that means to us and what's important for y'all to know is that the reactants and the products must be equal to each other. Remember the lesson opener on Tuesday was, you looked at a scale, right? We said if the scale was level, then that means that both sides were equal to each other. We had the same mass. So with law of conservation of mass, it's either the same atoms or the same number of atoms or the same weight of the reactants and the products. And also remember that reactants are the things that are going to react in the chemical reaction. And those reactants are going to react with each other, and then they're going to produce your products. So it's kind of like your reactants are your ingredients into something, and your products is what comes out of it. Okay? So what we're specifically going to talk about are open and closed systems. So again, reactants and products must be equal to each other, but sometimes in real life scenarios, it may seem like they're not equal, but that's because it's in an open system. Okay? So we're going to be using this bag to help us demonstrate an open and closed system. So if the bag is open, that means that this is an open system. When it's closed, it is a closed system. Okay? All right, so I'm going to first show you what an open system would look like. All right, so I'm just going to quickly use my baking soda. Y'all shouldn't be doing anything yet. Just wait till the video's over to do your lab. All right, so I got a little bit of baking soda in here, and I'm gonna take my vinegar and pour some in there. So remember, notice the bag is open. This is an open system. So once I mix this vinegar with the baking soda, it starts to react. There's bubbles forming, but those bubbles have left the bag. So if I would have waited before and then waited after, it would seem like they weren't equal. But that's only because it was an open system and the gases were able to leave. Okay? So that's an open system. Just remember, open bag, open system. Okay? Now with the closed system, so there's two ways that you can do this. So if you have the chemistry kit, you will get out your little cup. Hopefully it doesn't blow away because it's windy out here. Get your little cup. I'll hold on to it. And you get a packet of Alka-Seltzer. And you get your baggie. All right? I need to grab some water. I'll be right back. All right, I've got my water. I didn't fill it all the way up because I don't want it to spill when I place it into the bag. All right, so got my water. I'm going to open my Alka-Seltzer. Okay, I'm gonna open my Alka-Seltzer and I'm going to try it with 2 in here. All right, so I'm gonna put 2 of my Alka-Seltzers in here, and then I'm gonna take my little cup and place it in here. Be careful, don't spill it. We don't want it to react yet. All right, so remember we're demonstrating a closed system now. So I'm gonna close the bag almost all the way. I'm gonna leave a little bit open here just so I can, I'm gonna squeeze all the air out so it has somewhere to go. All right, so I'm gonna be careful. I'm gonna squeeze as much air as I can out of the bag and then close the bag. All right, I'm gonna put that aside and show the people that have the baking soda and vinegar how to do it. So you're gonna take your baggie and you're gonna have a bowl, a shallow bowl. And if you put your thumb and your pointer finger in each corner of the bag, well, let me step back. So what we're gonna do is we're going to, in order to keep our stuff separate, is that we're gonna put baking soda in one corner and vinegar in the other. So again, put your pointer finger and thumb in each corner, and then I'm gonna put that over the edge of the bowl. So the bowl helps keep it separated. All right, and then I'm going to open it, and I'm going to start with my baking soda. So take about a tablespoon of baking soda and put it in one corner of the bag. Be careful and try and keep it out of where the vinegar is gonna go so they don't mix. All right, and then you're gonna take your vinegar and don't do too much. I'm probably gonna do like a couple tablespoons. And again, be careful to not let the vinegar and baking soda mix yet. All right, and then just like I did over here, I'm gonna close it almost all the way. Leave a little bit open, if you can see that, and squeeze the air out. When you're squeezing the air out on the vinegar side, make sure you don't press the liquid and make it react and mix it together. All right, so I'm gonna close all of this out, get as much air as I can, and then zip the bag and make sure it's shut. All right, so now when we mix now that we have our closed systems, the bags are closed, the gases are gonna be trapped in the bag. Remember when we mix this, or when I mix this, the gases were able to leave in that open system. So now in my closed systems, if you have the water and Alka-Seltzer, just pour the little water cup over and mix that together. I'll let that mix. And then if you have the baking soda and vinegar, just lift it off the bowl and let those two mix together. All right. Now this is a chemical change because, well, first of all, if you feel it, with both of them, it feels cooler, right? There's a temperature change. And also there is a gas produced. See how the bag was filled up with air now. So in a closed system, even though if we weigh the open system and closed system before, they weighed the same, the open system will seem like it has lost some products, but it hasn't, right? They just left. They just went out into the air. And then in a closed system, all the products were able to be trapped in here. So if we weighed it, it would weigh the exact same as it did before we reacted it. So the main takeaway from this is that the law of conservation of mass, right, states that matter cannot be created or destroyed. It can only be transferred. So in this open system, it was transferred out of the bag. It went into the air. That doesn't mean it disappeared off the face of the earth. Those products still exist. They just aren't in this baggie. They're not in this system. And then a closed system with a closed bag, the products and reactants are going to weigh the same, going to be equal, because they were trapped in here in this closed system.